it goes through stations A, B, C, and D, right? So A to B, there will be a direct connection. B to C, there is a direct connection. C to D, there is a direct connection. That means for this one particular train, how many rows will be there in this uh, form of the data set? 3 rows, right? That is every row, a particular train can have multiple number of rows in this table. Why? Because we are just checking that it goes through which two consecutive stations. So if a train has, let's say, 4 stations in its route, then there are 3 such occurrences, right? A, B are consecutive, B, C are consecutive, C, D are consecutive. That means in this particular table that is given, here the train numbers are not unique, correct? So train numbers can repeat. Like this 12259, this might have 2 or 3 more entries depending on how many stations are on its route. But the important thing is that this departure and arrival, right? These two stations here, these two stations must not have any other stations in between or any stops in between. So these must be consecutive stations, and this is the distance covered by this train to go from station I to station J. Okay. So for example, the rth row tells us that train T, that means R means any random row you pick. Like if I take the first row, it tells us that train T here 12259 departs from station I, that means here station index 0, and arrives at station J, station index 1, and covers how much distance? 266. Right. Okay. So in other words, the rth row in this table corresponds to 2 consecutive rows in the card for train T. Basically, what this means is that for one row, there can be many number of, for one train, there can be many number of rows in this table. So each train T will occupy multiple rows. Now this scenario itself is modeled as a graph and it is represented by a matrix A. So I hope everyone knows how to convert a matrix into a graph and vice versa, right? So if I have a graph and I want to convert it into the matrix, what are the rows and columns of the matrix? The nodes, right? So in our case, this graph represented by these different trains. So we are mapping it all into an adjacency matrix, right? Here, what does n represent? This n that is given, what is written here? There are a total of n stations. So this is the number of stations, right? Okay. So each node in the graph corresponds to a station. So if there are n stations, how many nodes in the graph? N different nodes. Assume that the value of n is already given to you. So we don't have to worry about how many stations are there. Just think of it as n. We have to consider this following pseudocode and find out what it's doing. Okay. So simply this particular table that is given to you, this works on n different stations with as many trains as there are in my data set. I am checking that for each station, how many consecutive stations it, for each train, how many consecutive stations it passes, right? Okay. Now let's check the pseudocode. So first we have an empty dictionary S. So while table 1 is more rows, so we are going through the train data set now. For every card in the train data set, now what we are doing, so you will populate this S dictionary. Okay. By looking at this, these lines of code, can you tell me what is the outer key of this dictionary? This is a nested dictionary, right? Because we can see 2 box brackets are there. That means what is the outer key of the dictionary?
Sequence number, which is
Sequence.
indexed by station.
Correct. So sequence number is the uh, key, outer key of the dictionary. Okay. So we are going through this, okay, this data set. Here sequence number starts from 0, goes up to m minus 1. So some m rows are there. So this sequence number is your outer key. Now for each sequence number, there is a nested dictionary, right? That means here, if S is a dictionary, let's say 0 is a sequence number, against that there is another dictionary. Now inside this dictionary, what is stored? One key is the train. So if I go along to my this uh, data set, let's take the first train, 12259. Right. So against train key, it will be 12259. Then we have departure, arrival. These are all different keys, right? Distance. So for each sequence number, how many keys are there in the nested dictionary? 4 keys: train, departure, arrival, distance. Okay. Now this S, once this S dictionary is populated, what will it contain? Mhm. For every sequence number, what does it contain?
All four entities, train, depart, arrive, destination.
Right. So for each sequence number, there is a nested dictionary which contains train, departure, arrival, distance. Okay. Now you are creating a matrix A, which is of order n cross n. N is again number of stations. Okay. So now we have an n cross n matrix. Now for each R in rows of A and for each T in columns of A. Rows and columns of A are what? Just the station sequence numbers. So it is 0 up to n. I'm sorry, 0 up to n minus 1. Right, n stations we have. So those are present in R and C. That is rows and columns of A are nothing but station sequence numbers. So for every such row column combination, we are assigning a dictionary. That means every cell in this matrix A is nothing but a dictionary. Right. Initially it is an empty dictionary. Now what you are doing? For each X in keys of X. What are the keys of X? The sequence numbers, right? 0 till m minus 1. So that many rows we have in our table. So for each of these X values, that is each of the sequence numbers, in keys of X will give me a list of such sequence numbers, right, till m minus 1. So for each sequence number, we have, what are we creating? We are just populating the matrix now, right? Now in the matrix, each cell is a dictionary. What does it contain? So A of R of C of T means R means what? S of X of depart. So now you go on to the S dictionary that we previously created. X was what? Sequence number. Right. So if I say S of 0, it will give what? This dictionary that we created. Right. This is S of 0. So S of X of departure. So that will fetch this value, whatever is the departure station. So that will be stored in R. For arrival station, the index will be stored in C. The train number will be stored in T, and D represents the distance to travel from the departure to arrival station. That means in A matrix, for every row and every column, what are we storing? This RCT, what is this representing? R is the departure station, C is the arrival station, T is the train, and correspondingly we are storing the distance. Right. So ARC, if it represents a dictionary, in the dictionary the key is the train and the value is the distance between these two stations. Is the matrix A clear? Anyone has a doubt? Okay. So S
And
is,
uh,
yeah.
then A will store what distance between two
So
stations, like
A is a matrix, right? A is a matrix. Now for every row column, it has a cell that is ARC, correct? So now against each cell, what is stored? An empty dictionary. So we are just populating that empty dictionary here. R and C represent what? Arrival and departure stations. Okay, these are the values. Now against this ARC, this dictionary that is stored, inside this dictionary, what is present? T, which is the key. So R of C of key. Okay. So RC is the dictionary, T is the key of the dictionary. ARC is the dictionary. T is the key. What is the corresponding value? The distance to travel from R to C. Got it?
yes, got it.
Okay. So now just remember what is S and what is A. Okay, the questions will be based on these. The first statement is, if IJ is a pair of stations, which of the following statements about the dictionary AIJ are true? Okay, so we all know that what does AIJ represent? It will represent a dictionary of this format where it stores what? All the trains that pass through these two stations consecutively, right? There can be more than one such trains which can pass through. Okay, let's for example take A of station sequence number 2 and station sequence number 3. Against that, we have a dictionary. Let's say the train 12259 passes through these two stations with some distance d1. Again, let's say some station train number 13351 passes through these two stations consecutively with distance d2. So there can be a number of trains that passes through these two stations consecutively. So all these trains, it's to the distance values are stored in this dictionary, right? For A23. So if Aij is a pair of stations, now just here exchange 2 and 3 for I and j. So what does Aij represent? That is what they're asking. See the first option. Each key corresponds to a train that goes from I to j without stopping at any intermediate station. Is that correct? For Aij, we have a dictionary like this. Here, each key is what? What is the key? Train number. What does the train number represent? That this train passes from station 2 to station 3 using this much distance. So is option A correct? Is it a train that goes from I to J without stopping at an intermediate station?
Yes, ma'am.
Yes, this is correct. Because we already told you in the data set that is given that it is just for intermediate stations. I'm sorry, not intermediate, consecutive stations. Okay, option B is saying this is an MSQ. So option B is saying each key corresponds to a train that goes from I to J. It may stop at multiple stations. No, it may not stop, right? Because in our data set, it is said that those are consecutive stations. Option C is the value corresponding to key T of the dictionary is the distance between stations I and J on T's route. That means if I take this train number 12259, the value stored against this D1, this value is what? Distance traveled to reach from 2 to 3 by this train. Is this correct? Option C. Yes. Option D. The value corresponding to key T of the dictionary is the minimum distance between stations I and J on T's route. Is it the minimum distance for any train T?
No, ma'am.
So which one is the correct options here? A and C. If we want to find out what is the minimum distance to go from station 2 to station 3, then I'll have to compare the distances covered by all the trains that go in this route, right? That okay, train 1 goes from station 2 to 3 in distance D1, train 2 goes from 2 to 3 in distance D2. So you have to compare all the distances to find out the minimum one. So first question is clear for everyone. Any doubt?
Yes.
Okay. Okay. See the second one. What does the value length of keys of Aij represent? Again, remember Aij means there is a dictionary which is containing trains as its keys and distances as its values. These trains are the trains that pass from I to J covering D1, D2, these distances. So what is length of keys of Aij? That means keys of Aij will give me a list of these trains, right? These are the keys. So what is that value? Option A is saying it is the number of trains that go from station I to J that stop at least at one intermediate station. Is this correct?
No, ma'am.
Option B, without stopping at an intermediate station.
Yes, ma'am.
Okay, option D is correct. Option B is correct. This is MCQ, but still let's see the other options. It is the number of trains that go from J to I without stopping at an intermediate station. So this ordering is very important. I am checking for I to J, not J to I. Right. For that, there is a separate matrix entry that is AJ of I. So this is wrong. And D is it is the number of trains that go from I to J that stop at most one intermediate station. So there are no hops between these, right? I hope you have done the procedures, those n hop, n minus one hop, right? One more hop, these procedures. So you know what is hopping? That is, if I have a station A and B and I can directly go, then that's the direct route. If I have to go via an intermediate station, then this is a one hop route, right? So option D is also wrong. Okay. Question 3, this is also based on that same procedure that we did. Okay, just we are building on that. So now IJ min, this is a procedure that accepts a pair of stations I and J. Okay, and the matrix A as input. So we have pair of stations I and J and matrix A as input. It returns the train which goes from I to J by covering the least distance. Okay, so what does the procedure take? It takes I, J, which are station numbers. Okay, and matrix A that we built in the previous question, that matrix A of ij that we were doing. So these three things are parameter. Now, what does this procedure do? It returns the train which goes from I to J by covering the least distance. So just that question that I was saying, that how to compare the distances. It is that procedure. That now you want to know that to go from consecutive stations I to J, which train takes the least distance, right? So it will give you that train number without stopping at any intermediate station, that is direct route. So if there is no train between these two stations, the procedure returns -1. Now the pseudocode might have mistakes, so you have to point out. Okay. So between some station, some combination of ij, if there is no route from I to J via a direct train, then you have to return -1. So in the procedure C, first we are checking if length of, okay, first again we discussed what is length of keys of A of ij. What does this term represent? Number of
Number of trains.
number of trains that go from I to J in a direct route, right? So all of
Yes,
those 10 in a list and the length of that list, that is number of those trains. So if no such train exists, then the length of keys will be 0. In that case, we are returning false. So is it up to this? Is it all correct? That is, if there is
Yes,
no
ma'am.
train between two stations I and J, we are returning false, but we have to return -1, right? So this should be return -1. So line 3 is an error. So if I fix this, then let's move on to line 5. So first you are filtering out those for which there are no trains between these two pair of stations. Now, if there exists some train, that is, if the if statement is wrong, right? That is, we have some trains running between I to J without any intermediate stops. In that case, you come to line 5. Now, in this train variable, what you are storing is first of keys of ij. Keys of ij is a list of trains that go from I to J. What is first of that list? The first train, right? So, for example, let that be train T1. In min variable, we are storing. So, what will this return?
distance between the stations.
Distance between I to J traveled by train T1, right? So, this is that distance. Let's call it D1 currently. Now, for each k in rows of ij, okay, each k in rows of ij, what does aij mean? First of all, can I say it like this? Rows of aij. Is this a valid statement? Is aij a matrix?
Mm,
No, right?
No, ma'am.
Aij is a dictionary. So I can't have rows of dictionary, right? What I want to do is I want to go through each of the trains that run through these two stations, I to J, and I want to compare the distances. So what should I write here instead of that? So this should be
Keys
for
of
each
AI.
k, correct, keys of aij, right? We want to traverse through this list of keys and compare. So the comparison is very simple. You just have to find the minimum distance, right? So just first you store the distance for the current train. That is aijk. K is a current train. And then you compare if this distance is less than the minimum distance, that is this one that we initially store as D1, and you update it like just normal minimum finding procedure. So min will be equals to that assigned to that new distance if you find a lower distance. And the train is also assigned as the current train, which has the minimum distance. And then at the end, you're returning train. So are there any other errors that you can spot?
No, ma'am.
So line 3 and line 7, we have found errors. Let's see. Error in line 3 and error in line 7. So there are a lot of options. Let's see. Correct one. Yeah. So options A and D. Right. Is this procedure clear for everyone?
Yes.
Let's go to next question. This is a very simple procedure. See, again, I and J are what pairs of stations. So, which of the following statements are true after executing the pseudocode given below? Okay, this is again MSQ. I have a variable I to J. Okay, I to J. It is initially assigned false. Then I'm checking if length of keys of Aij is not equal to 0. Only then this length of keys of Aij, if it is not equal to 0, then the if statement will be true. And I can set IOJ to true. So what does length of keys of Aij not equal to 0 mean?
Number of trains are not the zero between the statements.
Actually, here I think the parenthesis is a little wrong, since I think it should close here. I mean, length of keys, right? I think it should be something like this. Okay, so keys of Aij gives me list of trains. I'm sorry. Keys of Aij gives me, yes, list of trains that run from I to J, and length of that keys will always give me the number of trains that go from I to J without any intermediate stop. If that list is non-empty, then it will be not equal to 0. That means there exists at least one train which goes from I to J directly. If that is the case, that there is at least one such train, then I to J variable will be set to true. Again, J to I is a variable which is set to false. Same thing I'm checking. If there is a train from J to I directly, that is length of keys of A of Ji are not equal to 0, that means some train exists that goes from J to I directly. Then J to I will be set to true. Now in line 9, I both J. This is a variable which is set to false. And in line 10, we have an if statement which is saying if I to J and J to I, that means what? When will this give true?
Both are true.
When both are true. Then I both J will be set to true. Right? So basically, what does this entire code means that I am checking if there is at least one train from I to J, and if there is at least one train from J to I directly, then only I both J, this will variable will be set to true. Right? If any of them doesn't have a train, that means if I can't go from I to J or from J to I directly, then I both J will remain false. So now you tell me, looking at the options, if first option, if I to J is true and J to I is false, then I both J is true. Is this correct?
No,
No.
ma'am.
Second option, if both are true, then I both J is true.
Yes.
Yes, ma'am.
This is MSQ, so let's see the others. If I both J is true, then I to J is true and J to I is true.
No, ma'am.
So when will I both J be true? When both of these are true. So if I say I both J is
Yes.
true, that means I to J is also true, J to I is also true. Right?
Mm.
Option D, if I both J is false, then I to J is false and J to I is false. Can I say this directly?
No, ma'am.
I can't say both are false, right? I can say that at least one of them is false. So this option is not correct. This option is also not correct. Why? Again, I cannot assume that I to J is false and J to I is true. All I can say is one of them is at least false. So option if is saying I both J is false, then I to J is true, J to I is false. Same logic. Option J is if I both J is false, then I to J is false or J to I is false. Is this correct?
Yes, ma'am.
Right. So or that means either or both of them are false. Okay, so both way it works. Here only this option is correct. If there was another option, so basically this would be a better option if we write that if I both J is false, that means either I to J is false or J to I is false or both are false. Okay, this is clear for everyone. Any doubt?
No, ma'am.
Okay, okay, let's come to this question 5. So sum proc is a procedure that accepts three parameters: a train, a station, and the matrix A. Okay, so we have train, station, matrix. This is the same matrix A, okay, that we computed in the first question. So which of the following statements about its return value are true? Okay, so for each R in rows of A, what are rows of A? Remember A, I, J. What is this I value?
First station.
Any station number, right? That means rows of A are just station numbers. Correct. List of station numbers. So for each of those station numbers, what am I checking? If is key. So for this dictionary, that is A of R of whatever station you have passed here. Okay. That means A of R of station. This is a typo, this is train. If this train that you have passed as parameter is a key of this dictionary, A of R of station, what does that say basically? That this train goes from R to station without any intermediate stops, right? So if it is a key, then I can enter the if block. Up to this, everyone is understanding, right? Any doubt? Okay. So for each C in columns of A, again, what are columns of A? Same station numbers, right? So if in this dictionary also that same train is a key, that means this train also goes from station to C. Okay, let's take an example. Let's say that train is T1, station is sequence number 5. Okay, now let's start with this. So first I'm checking is key, line 3. Okay, A of, let's take R as the first station 0 and station as this 5 that I've passed, and T1. So this means that if T1 goes from 0 to 5 directly, right, no intermediate stops, then this will give true. Again, for each C in columns of A, that is, if this is true, then only I'm checking for the columns, right? Then I'm checking that if is key, let's take C as station 1. Okay, so can I go from station 5 to station 1 with this same train? If that is also true, then return false. So if both of these things are true, what does that mean? That this station 5 is an intermediate station in this train T1's route. Can I say that? Station 5 is an intermediate station in train T1's route because it goes from 0 to 5, right? And again, it goes from 5 to 1. So can I say it is an intermediate station? Yes, no.
Confusing, man.
Look, I am saying that here R and C are nothing but station numbers. Okay. So we are checking for all possible combinations of this R and C. For a particular R, where I'm saying that let's say R is 0, that is station number 0, C is 1, that is station number 1. Let's call the train I passed as parameter as T1 and the station I passed as station number 5. So if there is a train T1 that goes from 0 to 5 and the same train goes from 5 to 1, then can I say that this station 5 is an intermediate station in train T1's route?
Yes,
Yes.
ma'am.
Okay. If that is the case, then I'm returning false. When am I returning true? See, this for each block. Okay, this for each block closes here and this one closes here. So there is a return true here. When will this be executed? Let's say if there is a route, okay, is key. I'm keeping the same example. So if train 1, T1 goes from 0 to 5, okay, this is true. But it doesn't go from 5 to 1. This is false. In that case, this return false will not happen, right? Instead, we will come out of this inner for loop and we will return true. Understood? That means when will I return true? See, for what station will this ever happen? Train T1 goes from station 0 to station 5, but it doesn't go from station 5 to station 1 or for any other station basically. Since I'm checking for all C, that means it doesn't go from station 5 to any other station. When is that case going to happen? that a train goes to a particular station S1, let's say, and it doesn't go to any other station after that. So what does this make station S1?
That was the end station.
Last stop.
Last stop, correct. So if my current station is the last stop in a train's route, then I will be returning true. When will this return false happen? When none of the conditions work, right? That means, again check. If for this station 5, okay, this if condition fails, that means train T1 doesn't go from 0 to 5. And there is no chance of checking the inner one because the outer if failed. In that case, you can go to this one, return false. So when will this happen? When will this happen that a station
The train
the
doesn't
train
pass through
T1,
that station.
the train doesn't pass through the station, right? It is not a part of the train's route. In that case also false will be returned. So false is returned in two cases. One case, the station is an intermediate station in the train's route. Another case is when the station is not in the train's route at all. And true is only returned when the station that you have passed is the end station in a train's route. So now look at the options. Some proc returns true if station is the starting station for the train. If it is a starting station, okay, then will the first if condition be true? Can it go from R to station if it is a starting station?
No.
No, because station is the starting station. You cannot be coming from some other station, right? This is the start point. So option A is wrong. See, because if this condition fails, then you will directly come to return false. Some proc returns false if station is the starting station for train. This is correct. If it is the starting station and the first if condition fails, then you directly come to this return statement. Right. Now,
Yes.
check option C. Some proc returns true if station is the ending station of a train. That's correct. Because the outer if is satisfied, the inner if is not satisfied. That is, you cannot go anywhere from this station, but you can reach this station. So only then you return true. So C is also correct. D is D correct? Some proc returns false if station is the ending station.
No.
No. E is saying some proc returns true if station is an intermediate station on train's route. If it is intermediate, will I return true or false?
False.
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 False. So option E is wrong. Option F is saying some proc returns false if station is intermediate station. This is correct. Option G is some proc returns true if station is not on train's route. If it is not on train's route, will I return true or false?
False.
False. This last false. So G is wrong. I think there's one more option here. So some proc returns false if station is not on train's route because then both if conditions fail. So the correct options are B, C, F, H. Let's match it once. B, C, F, H. This is clear for everyone, this question?
Yes, ma'am.
Now 6 to 7, again, this is an intermediate question. Okay, this is different from the previous one. Okay. So assume that there are n stations in the train data set, indexed from 0 to n minus 1. Now consider a graph with stations as nodes. If there are n stations, there are n nodes. There is an edge from station I to station J if and only if there is a direct train from I to J. Right, that is, I can directly go from I to J, then there is an edge in the graph. The graph is represented by, again, a matrix which is called direct matrix. So direct IJ1. This means what? There is a train that goes directly from I to J. Only then direct IJ entry is 1. Okay. So you assume that this direct matrix is already populated, it is already calculated. Now station J is reachable from station I if we can find a non-empty sequence of trains that take a passenger from I to J. That means if I to J is not directly reachable, there is no direct train between I to J, then also if I can find some route like this, that train 1 goes from I to K, then train 2 goes from K to J. If I can find a route like this, then I can say that J is reachable from I. Not directly, but it is reachable. Right. In other words, J is reachable from I if there is a non-empty sequence of edges that connect I to J in the graph. So there is an edge between I to K in the graph and an edge between K to J in the graph. So indirectly, I to J is connected by trains T1 and T2. Right. Okay. All right. So the following pseudocode computes a matrix B of identical dimensions as direct. That means these two are both same dimension matrix. If direct is n cross n, this is also n cross n. So in this matrix B, Bij is 1. This represents what? That J is reachable from I. I am not asking that it is directly reachable or not, but can I reach J from I by using multiple trains? Right. So all other entries of B are 0. Okay. So when I say reachable, J is reachable from I, that includes the direct trains also. That I to J there is a direct path, then it is also 1. But I to J there is an indirect path, like the one I drew, I to K, then K to J. Then also the entry is 1. Okay, all other entries are 0. Now look at the pseudocode. N is the length of keys of direct. What are the keys of direct? Direct matrix. What are the keys? Station numbers. Right? So keys of direct will give me what? The list of station numbers, right? And length of keys means the total number of stations in the data set. That is n. B, I'm now creating the B matrix, which is of the same order as direct matrix. So create matrix n cross n. So now B matrix is created. So for each row are in rows of direct. Rows of direct are again nothing but station numbers. Columns of direct are also station numbers. I, J, these all represent nothing but station numbers, right? So for every possible combination of RC, that is every possible row column combination, BRC is equal to direct side. So what is happening in this part? Anyone can explain?
You're just copying the stations which are directly connected.
Correct. So everything that was there in direct matrix is now again present in B matrix, right? All the direct paths are mapped. So if from I to J there was a direct path, now it is also a path in B matrix. That is the entry is 1. Okay, but we also need the indirect path. That is if J is reachable from I using hopping. So now since we have got all the direct paths out of the way, let's have hops as a variable which is 0. So how many hops can I have if I have n stations between any two stations? How many maximum number of hops can I have? N minus 1, right? Basically n minus 2. If you have n stations and you want to go between any two stations, so you can have a maximum of n minus 2 hops. Is that correct? Let's say I have,
Yes, because the last station will be the second.
see, if I have 4 stations, okay, I want to go from 1 to 4. What is the maximum number of hops I can do? 1 to 2, then 2 to 3, then 3 to 4. Right? So how many hops is that? 1 to 2 is 1 jump, 2 to 3 is 1 jump, 3 to 4 is 1 jump. It means I had 2 intermediate stations. Right? So n minus 2 is the maximum number of stations that you might jump between the paths, right? If n is 4 in this case, that it comes up to 2. That means this is that n hop problem that we learned, right? That between any two stations, I can have a maximum of n minus 2 number of hops. So while hops is less than n minus 1, okay, this is my stopping point. That is, I have reached all hops, no more hops are possible. If still I haven't reached I to J, then it is not reachable, right? So while this condition is true, that my number of hops hasn't exceeded n minus 2, then B will be assigned one more hop procedure. So one more hop B. So what does one more hop B now does? To come to the procedure definition. Here, B matrix is taken as your parameter, right? So for each R in rows of B, each C in columns of B, these are again station numbers only. You have to fill in the blank here. That how am I calculating this thing? How am I populating this B matrix, right? And whatever this returns, so it will return the B matrix only and store it in, that is B matrix is updated here. And then hops is incremented by 1. That means we have done 1 hop and then we have reached this state. Okay, so how many hops we'll do in total is at most n minus 2. So my job is what? That I want to find all the indirect paths and set them to 1, right? If I find for any BRC, there is an indirect path from R to C, then it should be set to 1. Okay, because direct paths are already taken care of, so don't have to worry about that. So what is that condition to find out? Now you have to check that options to find out. Okay. So the pseudocode is incomplete. You have to select the correct code fragment. So again, remember my goal is to check if there is an intermediate station K such that R to K there is a route, K to C there is a route. Okay. First option is saying for each K in columns of B. Okay. Again, K is a station number. If B of RC is equal to 1, B of RC equal to 1 means what? It is already a direct route, right? If I see that for this R and this particular C, there is already 1 present in the cell. That means there is a direct route, nothing else to do, exit loop. Okay, but if this if condition fails, that there is no direct route, then you have to check that for every intermediate, every other station K, right? Columns of these list of all stations. You have to check that if R to K there is a route, direct route, and K to C there is a direct route. Then I can say that R to C also there is a route. That is C is reachable from R, and then I can accept. So is option A correct? What do you think?
Ma'am, may I see the question once?
Yeah, this is the code. Okay, so we are creating this matrix B. We already have the direct matrix, which direct ij is equal to 1 if there is a direct train from I to j. Now in this B matrix, which is the same dimension as direct matrix, we just want to make those cells as A where j is reachable from I, but might be directly, might be indirectly. So if there is some intermediate station that I can go from I to K, then K to J, then also ij value should be set to 1 because j is reachable. Okay, so it is, you just have to fill up this part of the code, that how to populate that B matrix. So initially we have copied all the direct matrix entries also, so direct routes are already sorted. So now about the indirect routes. So that means you have to now hop, right? 1 hop, 2 hops, as many hops as it takes to reach from I to J. But that should not, uh, it should not exceed this condition, that the number of hops should not be greater than equal to n minus 1, right? It should always be lesser, that is, it should be up to n minus 2. So I'm just asking that for every RC combination, okay, in B, that is for every two corresponding stations, how to fill up, how to know if there is a route from R to C. So first option is saying that if there is a direct route, that is RC entry is already 1, then you exit, do nothing. But if there is not a direct route, this if statement goes false, then I have to check that for every K in columns of B, that is every station, I have to check that is there a route from station R to station K directly, and is there a route from station K to station C directly. If both are true, then I can say that R to C is reachable. So that means this cell is set to 1. So is this option correct?
Yes, ma'am.
This
Yeah.
is correct. Option B is saying for each K in columns of B, if there is a route from R to K and from K to C, then directly set R to C as 1. Is this one correct? Here the
Yeah.
difference is, yeah, this is correct. Because we are just not checking for the direct routes, but that doesn't make it wrong, right? Because direct routes are already 1. I don't need to check that. This is extra line of code. You can just use this logic that if there is a indirect path, then obviously it is 1. And if it is a direct path, it should already be 1 because we copied direct matrix entries already. Okay, option C. Is it correct? Only difference is this, columns and rows. But that does it make a change?
No, I don't think so.
No, because columns are same, right? Just station name. So you can use these interchangeably. Option D, for K in columns of B, I'm checking if there is a route from K to R, and if there is a route from K to C, then I'm saying R to C there is a route. Is this correct?
Yeah, it is also correct, I think.
Is
No,
this
not
No,
correct.
no.
why it is not correct?
It
KR,
is go to K to R and
Right,
K
the
to
intermediate station. It
VK to
should be
C.
here I can go from K to R and K to C, but it's not like if I start at R, I can reach C, right? I need to
Yes.
find route between R
If it
to C.
was
But we can
BKC
go R
is
to
equal to
K
1, then
and
it
K
should be
to
okay.
C.
No, these are not interchangeable. See, BKR and BRK are two different things, right? Here, when I say B of K and R, that means there is a route from K to R. I can't say that there is a route from R to K. For that, the entry is B of RK. Okay. So I can go from K to R and I can go from K to C. But where am I checking if I can go from R to C?
Ma'am, I'm saying that if we go R to K, then
Can
we
we go
go
R
K
to
to
K?
C.
Then that for that you need a condition, right? You have to check that if you can go from R to K. But I am checking if I can go from K to R. Is this correct? Like
Okay.
here, checked that I can go from R to K. This is fine. So K becomes intermediate. Here R, here nothing is intermediate basically. K to R you can go, K to C you can go. These are two different things, right? It's like this, the graph, that I
If
can
we
go from
do,
A to B and A to C.
okay. If we can't go from R to K, then it is not right.
Yeah, then it is not possible.
Yeah.
So this option is wrong. So all the other three options are correct, I think. Yeah. Okay. Anyone has a doubt here? This question? Okay. This one you should be very easily able to solve. This graph is given to you where n is equal to 5. So there are 5 different stations. Think of them as station numbers. Matrix B is computed using the above pseudocode, right? You know what matrix B is now. So for matrix B, if a cell contains 1, right, for a station I and station J, if Bij is 1, what does it mean? That I can reach J from I, either via direct route or via indirect route, right? So you have computed that matrix B. What is the value of sum after executing the following pseudocode? So the pseudocode is sum is initially 0. For each row and each column combination, that is for each B of ij combination, we are just adding up the value in the sum. That means for all the BRC combinations that have 1 stored in the cell, you can just add those ones. So how many ones will be here? That means how many direct or reachable paths? Here, first tell me, here, what type of a graph is this? This is a cyclic graph, right?
Yeah, right.
Cyclic. So in cyclic graph, what is the specialty? That every,
That yeah, that they are connected.
right, that means every node can be reached from every other node. Okay.
Yeah.
So for every node, if I can come to node 0 from all other 4 nodes, right? Every node, so every other node there is a path. So for every Bij, there should be a 1 assigned. Is this correct for this graph? Ij is any station. For this particular,
Yeah.
every entry is
Because it
1.
is yeah, because it is cyclic. So yeah.
Yeah, so I can go from any node to any node. Okay, everything is connected. Then what will be the sum? How many nodes are there in the graph?
Five.
5 nodes are there. So now think of the adjacency matrix. How many rows will be there in the adjacency matrix? 5 rows for each of the stations, 0, 1, 2, 3, 4. 5
Yeah.
columns, 0, 1, 2, 3, 4. This is the
Right.
adjacency matrix, right? And all the cells are 1. So now just find out the sum. How many cells are there? 5 rows, 5 columns. 5 cross 5, that is 25 cells. Each cell contains the value 1. So sum
25
125
cell
times.
will be, yeah.
So 25 is the
Mhm.
answer.
Yeah.
Everyone got this? Yes, any doubt?
Yeah. No, ma'am.
Okay. These are very scoring questions. This type of question you can get in NTERM. There will be some graph related questions, right? So this is question 8 to 9. So this is again comprehension type. The following pseudocode is executed using trains dataset. As discussed in the lectures, assume that trains is a dictionary with train number as key mapped to a list of stations which the train runs through. That means trains dictionary looks like this. The keys are the train number and the corresponding value for every key is a list of stations through which this train runs. So 12281 starts at Bhubaneswar, then goes to these stations before reaching New Delhi. Right, that's the end station. So this is trains dictionary. In this example, the train with train number 12281 starts from Bhubaneswar and reaches New Delhi via Balasore, Agra, Varanasi, and Kanpur in the order. Okay. So let common numbers L1, L2. Let this be a procedure which returns the number of common elements between L1 and L2. I don't know what L1, L2 are currently. Okay, this is just some procedure which takes some L1, L2 and it returns the number of common elements between these two lists. So L1, L2 are some lists. Okay, now you observe the pseudocode. So I have a procedure called do something. Okay, this takes this trains dictionary as parameter. It has I set to 0, index is an empty dictionary. So for each T in keys of train, what are keys of train?
Train number.
List of train numbers, right? So T1, T2
Yeah,
like this,
list
the
of
list of train numbers. So for each of these train numbers, in the index dictionary, I'm creating a key. And against that, I'm storing I. That is, I'm indexing basically. So index dictionary looks like this.
Ma'am, index would be a list of stations of that these trains,
Index is
right?
a dictionary, right? Index is initialized as a dictionary.
Oh,
That
yeah,
means it has
okay.
key value pairs. So now I'm just populating this index dictionary. How? For each T in keys of trains. So I know that keys of trains are train numbers like T1, T2 like this. Index of T is set to I and then I is incremented before the next iteration. That means let's say the first train is T1. Index of T1, that is T1 becomes key. What is the corresponding I value? I starts from 0. So T1 is assigned the sequence number 0. Next I is now incremented to 1. Next train is T2. So index of T2 is set to 1. Then like this T3 is set to 2 like this. I will go until how many trains are there. So this is the index dictionary. Up to this, is it clear? Okay. N is length of keys of index. What are keys of index? Again, train numbers. Length of keys gives what? How many trains there are?
Yeah, total number of trains.
Total number of trains. That is N. Now, CSTN. This is basically common station. Okay. CSTN. This is a matrix of order n cross n. Okay. So now you can tell that if this is the order, that means in this matrix, what are the rows, what are the columns? Just train numbers.
What is the n to n? N comma n.
This is how to create a matrix. This is create matrix procedure. In these are the dimensions of the matrix, how many rows, how many columns, right? Okay. So I hope adjacency matrix you have covered. If you haven't, just watch the lectures once more for week 9 and 10 properly. Okay. So now this matrix is created CSPN. Okay, this is an n cross n matrix where n is number of trains in my data set. So for now, don't think about anything else about this C station, this matrix. Okay, let's see what they're doing. So for each T1 in keys of trains and for each T2 in keys of trains, that means I'm taking two distinct trains and comparing them. Okay, keys of trains is nothing but train numbers. So I'm taking T1 and T2, two distinct trains. How do I know they're distinct? Because I'm checking if T1 not equal to T2. So I pick two trains at random from keys of train. If they're not equal, then only I can enter this if block. In the if block, what is happening? C station. Now look at this carefully. C station is the matrix. How do we access matrix element for matrix A? I can write A of ij. This will give me the element in that cell. So here C station is the name. What is I? The index of T1. What is index of T1 in our example? 0. What is J? Index of T2. Index of T2 in our example? 1. So C station of 0 and 1. So in this matrix C station, 0 and 1. Okay. What is stored in this cell?
Ma'am,
That is,
how do we get this 0 and 1?
this is just an example I took. Okay. So I
Okay.
said that these are the trains T1, T2. I created an index for them starting from 0. So T1 index is 0, T2 index is 1, like this. Okay. So for two distinct
Okay.
trains, T1 and T2, if the index of T1 is 0 and the index of T2 is 1, okay, then C station of 0, 1. What does this cell contain in the matrix? Now I'm calling this common number procedure, which takes, remember, two lists and finds out the number of common elements in them. So is this a list, trains of T1, trains dictionary? If this is T1, this is the corresponding value stored, which is a list, right?
Yeah.
So basically, I am taking out trains of T1 is the list of stations through which train T1 runs. Trains of T2 is the list of stations through which train T2 runs. If they have any common elements or common stations between them, then that will be caught in this procedure. It will return the number of common stations between trains T1 and T2's routes. Is this correct?
Yeah, that's right.
So that is stored in this C station matrix. So basically here in the C station matrix, we just are representing the trains as the sequence numbers that I've indexed them in. Like T1 is represented by 0, T2 is represented by 1. So for any pair of trains in the C station matrix, what does it represent? The corresponding value stored in the cell, the number of common stations between these two trains route. And what is the procedure returned
So
in? Yeah.
okay, so the CSTN, CSTN stores name of stations and also the train number.
Not name. Okay, it looks like this. See, if I have, let's say, 4 trains, okay, T1, T2, T3, T4. T4 is index plus 3. Then CSTN is a matrix that looks like this 0, 1, 2, 3. Okay, these are the train indices again as rows also 0, 1, 2, 3. Now, if I see that there are some, let's say, between the routes of train 0 and train 1, there are 3 common stations. So CSTN 0, 1, this cell will contain 3 common stations. Okay, again between train 2 and train 3, let's say their routes contain 4 stations in common, then this entry will be 4. Got it?
Okay. Yeah, got it.
So this procedure will, after you have populated the CSTN matrix fully and the index is already created, then it will return the matrix and the dictionary index. Now the question is asking if CSTN ij, that is for any entry ij in CSTN matrix, if it is 0 for I not equal to j, that means for two distinct trains I and j, if the entry is 0, then what statement can be concluded? First is saying there is no route between stations with indices I and j. Are ij,
There is no two common station. There is no common station between I and J.
I and j are not stations, right? These are train indices.
Um,
First option is
yeah,
definitely wrong.
yeah.
So
Okay.
you are saying that I and j, this represents that there are no common stations between the routes of train I and j, correct? So there are no common trains between the stations with indices I and j. This is wrong. There are no common stations on the routes of trains with indices I and j. This is the correct one. Okay, so option C is correct. So this CSTN matrix is nothing but containing train numbers as rows and columns, right? The train indices that we created in the index. And for any two trains, it stores the number of common stations between their routes. If it is 0, that means there are no common stations. And the last question is saying, assume we start our journey using a given train T. So the train that I am using is T. Now consider the following procedures. They should return true. So we have a list of procedures here. These procedures should return true when it has at least one common station with all other trains. Okay. So if for a particular train it has common stations with all other trains, that means one row will be entirely full of one, right? If it has only one common station or whatever, the basically what this asks us to do is to check that if a particular train T has at least one station in common with every other train, right? Then only the procedure will return true. So first procedure train boarding 1, it takes the train T that I'm currently on and the train's dictionary. My job is to check whether this train T has a common station with every other train. Okay. So CMAT and index. Here I have called do something trains. That is the last procedure that we saw. So the last procedure was returning what? The CSTN matrix that we created and the index dictionary. So those two are now stored in CMAT and index. Now in K variable, I am storing index of T. Okay, that means the current train that I'm riding, what is the index of that train that is stored here in K? So for each I in columns of CMAT, okay, CMAT is nothing but CSTN. So what are the columns of this? What do the columns represent? CMAT?
Common station, like the train
No,
which
just the
have
train.
just the train having common station.
No, see, CMAT, okay, or CSTN. The rows and columns just represent train numbers. Okay, each of the cell represents the number of common stations. So if I say
Yeah.
columns of CMAT is
The
just train number,
Okay. So the train numbers.
right? Or the indices that I assign to the trains, right? So for
Right.
each I in columns of CMAT, so for each such index of train, I'm checking if I not equal to K. K is my current train index, the train that I am on. If I not equal to K, right? And CMAT KI is equal to 0. When will CMAT KI equal to 0 be possible? When there are no common stations between the routes of trains K and I.
Yeah.
So if I and K are separate trains and they have no common station in their route, then you return false. But when should we return true according to the question? When my current
They have
station,
common station.
my current train T, that is index K, has a station in common with every other train. Okay. So if it has a station in common with every other train, will this part become true ever? CMAT K of I is equal to 0.
No, not like it will return true when
No, no. Forget about the
IK
returning
is
part.
equal to 0. Yeah. Okay.
So the question is CMAT KI is equal to 0. This means that for any I, that means for any train I, there are no common stations between K and I. So my question is that it should return true when there are at least one common station with every other train. That means for every I value, there is at least one station in common with K. So if that was the case, then if K had a common station with every other train, then will this part of the question become true ever, that CMAT KI equal to 0? No, right?
No. Yeah. It
Because for
will become
every
one.
I value, yeah, it can become one or more than one if there are more than one stations in common. Anything, but not 0.
Yeah. Yeah.
So in that case, now assume that K has a common station with every other train. In that case, will I ever return false?
No.
No, because this condition will give false, right? And true and false is false. So we cannot enter the if block. In that case, you will just come out of the loop once you have gone through all the I values and return true. So is this procedure correct?
Yeah.
This is correct. Now see the second one, train boarding 2. Again, I am on train T. This is train's dictionary. You have a count which is set to 0. Now for each T2 in keys of trains are again train numbers. Okay, not index, just train numbers. This is the train's dictionary. So keys of trains is train numbers. So for each train number, I'm checking common numbers. What are the lists I'm passing? Trains of T, trains of T2. This trains of T is what? List of stations through which the train T passes. This train T is what I am on, right? Right. I am on this train and I want to find out whether this train has at least one station in common with every other train. So I'm just checking that for every train T2, okay, if common number procedure gives me greater than zero value when I compare these two lists, trains, that is stations in the routes of T and stations in the routes of the current T2. If I find that the value is greater than zero, that means there is at least one station in common between these two. Only then the value will be greater than zero, right? Then count is incremented. So you tell me if I have n trains in total, okay, I'm checking that this particular train T, which is also part of these n trains, this has a station in common with every other train, right? That means how many times will the count be incremented if it is true?
Times.
N
N
times.
minus 1, yeah. Yeah. Because T is one of them.
N times because, yeah. So T will also be compared with itself, right? For that also there will be a one, count one will be added.
Yeah, okay. Huh.
So total of n times it should be incremented if T has common stations with every other train. Now, once this is done, once count is calculated, in line 8, you're checking if count is equal to length of keys of trains. What is length of keys of trains? Total number of trains in the data set. That is n. Right? If there are n
Okay,
trains in
yeah.
the data set and the count is also n, that means that it is true. That this train T has a common station with every other train in the data set. That's why the count became equal to length of keys of train. Otherwise, it will give false. So, is this procedure correct?
Yeah, ma'am.
That means both the procedures are correct. Both of them can clearly determine whether this given train T has a station, at least one station in common with every other train.
Ma'am, can you
So,
explain line number 8?
in this second procedure,
Yes. Why we choose length of keys
length of keys
instead
of
of
train.
greater than 0? We can
Yeah,
also
see,
do that, no?
what is the concept that, for example, let's say my data set has n trains, right? Then how many keys are there in trains dictionary? N.
And
Okay. Now I am on this train T. I am supposed to check if this train T has a common station with every other train, including itself. Okay. Because when we run this for loop for each T2 in keys of trains, this also will take us to train T at some point because it is part of the data set. So if this train T has at least one common station with every other train, that is, it has a common station with n number of trains, right? T2 will change n times for n different trains. If there is a common station between each of these combinations, then how many times count is incremented?
n time.
N times. So if n is equal to n, that is, if T1 has exactly common stations with every other train, then only I am returning true. So this length of keys of train basically means total number of trains. Count should represent total number of trains, right? If you have a common station with every other train, including yourself. Just think of it like this. I have 4 trains. 1, 2, 3, 4. Okay. This particular train I am on. I want to check if this train has common stations with this train, this train, this train, and itself. So if it does, how many times will count be incremented?
N.
4 times. When 1 is
Okay.
compared with 1, when with 2, with 3, with 4, so count becomes 4. So if 4 is equal to 4, that is length of keys of train. If I have only 4 trains in my
Okay,
data
okay.
set, then I'll return true.
Procedure return false when
It will return
uh,
false when if count is not equal to length of keys of trains, that means
if
you
it is
don't have a
only
common
3 or 2
station.
or 1.
Yeah, if you don't have a common station with even one of the trains, then only it will give false.
Okay, okay.
So now see the options. Only procedure train boarding 1 works correctly. No. So both the procedures work correctly. Option C is the answer. Is this clear for everyone?
Yeah, ma'am.
Okay. So that's it. That's the week 10 practice assignment. Now for week 10 and week 11, I would ask you that week 12 doesn't have any content as such. So only this week 11 is left mainly. But week 9 and week 10 are very important for end term point of view, right? So the kind of questions that we solve today, this is the type of question you will get in end term, and at least there will be one question of this sort. This one, right? This, right? This type of graphical representation questions. So you can just practice some PYQs from these 2 weeks. Okay. All right.
Thank you, ma'am.
Yeah, thank you. That's it from my side. Join the Friday session again. We'll start week 11. Okay. Thank you, everyone.
Okay, thank you, ma'am.